All right, let's get right into it. Welcome to this rapid fire disruption briefing. If you're a high-level tech investor or a VC hunting for that next massive generational leap, you're going to want to pay very close attention to this. We're looking at a complete paradigm shift, a fundamental break from 80 years of legacy computing standards. It's a bare metal architecture known as the consensus hypervisor, and it's literally redefining the enterprise data center as we know it.
Okay, so imagine this. What if I told you that 10 terabytes of cloud data could fit into just 3 gigabytes? Seriously? Stop and think about the physical limits, the massive cooling costs, and all that expensive real estate tied up in modern data centers. The consensus hypervisor actually makes this happen through a process called recursive phase folding. It's kind of like taking this giant digital sponge and compressing it down to almost nothing, literally folding huge amounts of structured operating system data into a tiny physical residue. To put that into perspective, that is an exact 1,000 to 1 density collapse. 1,000 to 1. And this right here is exactly why the algorithms are lighting up and venture capital is swarming. In a normal system, if you want to spin up 1,000 virtual machines, you need massive amounts of RAM and storage. But here, the guests loop back to the exact same physical location to use it as a reference. So the storage footprint doesn't grow, it actually shrinks. Whoever owns this density ratio fundamentally breaks the current economics of server hosting. It is a massive FOMO trigger, for sure. So how do we actually get there? Here's the roadmap for this briefing. We're going to move aggressively through 6 sections. The legacy cloud bottleneck. Deterministic projection outpaces cloud. Zero-weight state market advantage. Speculative prefetch drives ROI. Integrating bare metal chaos thresholding. And finally, the ultimate competitive moat. Okay, section 1, the legacy cloud bottleneck. Let's dive into the disease before we look at the cure. We really have a classic David versus Goliath situation here. Goliath, in this case, is legacy computing. It is totally choked by the von Neumann bottleneck, just constantly bogged down trying to physically move data back and forth between the CPU and the RAM. It's incredibly inefficient. David, on the other hand, is the consensus hypervisor. Instead of relying on rigid physical memory mapping, it acts more like a topological lens. It actually uses mathematical resonance to bypass that whole legacy traffic jam, completely outperforming massive physical servers with smart, agile math. Which brings us to section 2. Deterministic projection outpaces cloud. So we're shifting away from physically storing data on magnetic platters, right? We're mathematically projecting it instead. The secret sauce is that by using deterministic data projection, you create these virtual resources that are mapped via algorithmic expansion. It's a concept known as pace expansion. And to be clear, this is not just some software simulation running on top of Linux or Windows. The consensus hypervisor is a Type 1 bare metal framework. It bypasses the host OS entirely and treats the bare metal CPU as a pure mathematical engine. Instead of buying incredibly expensive physical RAM for guest operating systems, the hypervisor just algorithmically generates the required memory pool. It projects it just in time from an encrypted seed, literally outpacing traditional hardware scaling. All right, section 3, zero-weight state market advantage. This is where we pivot to the sheer performance disruptor that's going to render traditional data centers obsolete, a zero-weight state. In deep tech jargon, this is the absolute holy grail. But in VC-friendly terms, it basically means the system never, ever halts. Traditional cloud architecture constantly deals with stutter or cycle drift whenever it has to fetch or verify data from physical storage. The consensus hypervisor totally eliminates that temporal lock. It uses predictive topology, meaning the guest OS is never just sitting around waiting for the hardware clock. It reads deterministic noise seamlessly and operates at the literal speed of the memory bus. So the crucial advantages here boil down to 4 main wins. First, the guest OS never halts because it's reading predicted noise that is mathematically correct almost instantly. Second, cycle drift, gone, completely eliminated. Third, cryptographic consensus runs flawlessly in the background. And fourth, it activates what's called the Neumann bypass. It skips all those unnecessary data hops for pure, frictionless execution that legacy silicon just wasn't built to compete with. Moving on to section 4, speculative prefetch drives ROI.
This right here is the core driver for market scale ROI because it fundamentally breaks the economics of server hosting. The architecture literally divides and conquers the workload. It completely decouples the heavy cryptographic verification from the actual data routing. So Core 0 runs completely unbound, speculatively predicting the next data routes based entirely on 10-bit hardware atoms. It completely ignores the heavy math. Meanwhile, Core 1 trails behind, asynchronously, handling all those intense cryptographic hash verifications. Because of this bifurcated architecture, a single physical workstation can run a ghost city of over 1,000 autonomous virtual workers. And here's the crazy part. These workers take up zero power. They're totally invisible until a piece of incoming traffic naturally vibrates their specific cryptographic key. Then they just blink into existence, do their job, and vanish right back into the math. The ROI of putting 1,000 enterprise-grade workers on one machine, it's simply staggering.
Section 5. Integrating bare metal chaos thresholding.
For the enterprise infrastructure buyers out there, you need to know this isn't just some theoretical white paper. This is a rapid-fire strategic playbook ready for immediate deployment on existing x86_64 and Arch64 silicon. It relies on 3 strict steps. Step 1. Bare metal memory barriers. We inject architecture-specific inline assembly to strictly enforce memory fencing, which keeps the projected storage from desyncing. Step 2. Chaos thresholding. Instead of forcing immediate entanglement and spiking the CPU, data actually exists in this probabilistic, chaotic state in the L1 cache until a specific entropy threshold is met. Then, boom, it collapses into order. And step 3, hardware-assisted preemptive paging. The hypervisor uses idle CPU cycles to pre-calculate the next probable state of the data, completely hiding the projection latency from the guest. We're no longer fighting the hardware clock, we're literally riding its natural entropy. And finally, Section 6. The ultimate competitive moat. Let's bring this briefing home. This is the absolute most disruptive market advantage of the consensus framework, the impenetrable security implications. When you compare this to legacy systems, the traditional zero-day exploit game just completely evaporates. Look at persistence. Legacy exploits love to hide in static storage, but consensus uses kinetic storage. There's no rest state, so exploits literally have no floor to stand on. Then there's privilege. Legacy admins can see everything. Consensus gives you sovereign invisibility. Even the master hypervisor just sees chaotic noise unless it has the guest's specific XOR fractal P. And scaling? Legacy means massive bloat. Consensus uses harmonic inheritance for that insane 1,000-to-1 density collapse. It is a mathematically self-healing, constantly moving target. And that brings us to the most mind-bending security feature of all, the self-routing data protocol. If you deploy this across a mesh of perfectly distanced nodes, the network itself literally is the hard drive. The data lives continuously in flight between the nodes, mutating as it rotates. Since there's a fixed physical latency, the storage capacity is actually the latency itself. If an adversary physically seizes a server, there is no hard drive to image. The standing wave of data instantly senses that latency collapse, and the data vanishes from that physical location in a nanosecond, safely rotating among the remaining secure nodes. It's an unhackable, unseizable, kinetic vault. So, as we wrap up this disruption briefing, I want to leave you with a final provocative thought. Take a real look at your current enterprise data center. Is your infrastructure a static target just waiting to be breached? Or is it a standing wave, mathematically invisible, and operating completely beyond the limits of legacy physics? The future of computation is moving from isolation by physical boundaries to isolation by resonance. The question is, are you going to ride the wave, or are you going to let it sweep you away?